In Unit 16, we learn about assembly drawings. In the objectives associated with this unit, we plan to explain the nature and role of assembly drawings in the industrial setting. We'll explain the different ways of creating pictorial and multi-view assembly drawings used in industry. We'll discuss the role of the sub-assembly drawing, and will identify and read information about the components within an assembly drawing. We also plan to identify sectioning techniques used to delineate component parts in an assembly drawing, and will identify and read parts lists information about assembly drawings that are drawn for multiple variations. In general, assembly drawings are those drawings that show the working relationship of the various parts of a machine, structure, or product as they fit and function together. For the scope of this text, drawings of inseparable assemblies such as welded parts or parts with inserts are considered in the same context as detailed drawings. Usually, each part in the assembly has its own unique part number. Within the assembly drawing, the part number is indexed and listed in a parts list on the drawing, as described in Unit 3. The assembly drawing usually provides the following: the name of the subassembly or assembly mechanism, as well as a part number that can be used in higher assemblies and inventory, a parts list or bill of materials, a visual relationship of one part to another in order to correctly assemble components, and overall size and location dimensions when necessary to provide critical information, and information that cannot be determined from the separate part drawings. Assembly drawings serve as the detailed drawings of the entire product, machine, or device. This drawing is often a multi-view drawing and may be sectioned in one or more views, although one may be sufficient to describe the assembly. While an assembly drawing may be made for a complete mechanism or machine, more complex machines and structures may require several sub-assembly drawings for subunits. Subassembly is a term for any assembly that fits within a larger assembly. Sub-assembly drawings are similar in nature to other assembly drawings. They include a group of related parts composing a subunit of a larger mechanism, such as a drill press spindle assembly, automatic transmission assembly, or drive sprocket assembly. In this drawing, the subassembly is a multi-view projection that provides information about a part composed of other parts. It provides identification about the group of parts as a new unit. The subassembly part number is used for inventory and process control. As with any assembly drawing, dimensions are not usually required because all of the materials are already manufactured and inspected, although the final dimensions of the subassembly can be included as well as any other dimensions that may need inspected or controlled. According to ASME Y14.24, the term detailed assembly is applied to an assembly drawing that also contains all dimensions for all features of the individual parts within the assembly. These detail assembly drawings are useful for very simple assembly mechanisms. The drawing shown here is a detailed assembly drawing. As shown here, the company saved documentation time and expense of showing dimensions of all parts in this one drawing. However, this practice can be problematic with respect to maintaining one print for individual components as well as the assembly. Unless the pieces of this item are all manufactured and assembled before arriving in inventory, tracking can be difficult. Diagram assembly drawings use conventional symbols joined with single lines to show piping flow and wiring assemblies. The drawing explains to the reader how to assemble parts, but the parts are shown as symbols only. Exploded assembly drawings show some or all of the parts separated from each other to help show the correct order or method of assembly. Exploded assembly drawings are really not a separate type of assembly drawing. Both multi-view and pictorial assemblies can be drawn in an exploded manner. Exploded assemblies are easy to read and understand when analyzing a mechanism or product. Thus, they are most often used for maintenance documents, service manuals, or parts request diagrams intended for the general public. A system is necessary for identifying the parts of the assembly. Most assembly or sub-assembly drawings use leaders to identify the parts. Many assembly drawings use balloons neatly arranged on the drawing to identify the parts. As defined in Unit 3, balloons are circles containing a find number or letter and are usually connected to leader lines as shown here. Section lines for different parts of an assembly drawing are turned at different angles, or the scale and spacing of the section lines may be different. This is important to keep in mind when reading an assembly drawing. All section lines assigned to any one part should all be the same angle and spacing. To clarify an assembly drawing with many section lines, it is also helpful to use the section line patterns representing the part material, rather than general-purpose section lines. Thin materials such as gaskets may have the sectioned area filled in solid. The type of section line used to represent a surface varies according to the type of material. However, the general-purpose section line symbol used in most section view drawings is that of cast iron. As mentioned in Unit 15, Detailed Drawings, purchased parts that do not need to be manufactured because they can be purchased from a vendor, do not need to be in detailed drawings, but, however, they may still be illustrated in an assembly drawing. Purchased parts are things like bolts, fasteners, and nuts, as well as springs, keys, O-rings, and pins. In section views of assemblies, fasteners do not get sectioned. In some cases, an application block is located adjacent to the title block. An application block provides the opportunity to indicate the larger unit, subassembly, or assembly for a particular part or subassembly. The application block usually has a column for the part number or assembly number entitled Next Assembly. Another column entitled Used On indicates a higher level of system number, such as the model number of the product in which the part or assembly is used. Additional quantity columns can be added to indicate the number of sub-assemblies required at the next assembly or total quantity used in the product. The application block can also be incorporated into the parts list. As discussed in Unit 3, title blocks and parts list, the parts list is a chart listing the parts within an assembly drawing. It usually appears immediately above the title block on a print. The following items are usually included in a basic parts list: the find number, which matches the number found within a balloon on the drawing; the quantity required, which indicates the number of item needed within the assembly; the part identification number, or PIN, which indicates the identification number assigned by the company to the part; the nomenclature or description, which provides an opportunity to name or describe the part. Nomenclatures may use a classification system for parts names. Descriptions generally do not have a particular system. Nomenclatures may use a taxonic nomenclature system for part names. This taxonic nomenclature system was influenced by the Swedish naturalist named Carolus Linnaeus, and is considered the father of taxonomy because in the 1700s he developed a way to name and organize species that we still use today. His two most important contributions to taxonomy were a hierarchical classification system and the system of binomial nomenclature, a two-part naming method. There are several companies and the military that use this system today. The system typically notates in this manner, shown on the slide. Take a moment and study the pattern to get a better understanding. For a more in-depth study of this, I've included a link to the website where I've extracted the images from at the end of this recorded lecture. Additional columns are often found in the parts list for assembly drawings. This is an example for an expanded parts list that incorporates the following columns: cage codes, materials, procurement specifications, the weight, notes about the part, code numbers, and drawing zone location. The cage code column appears on assembly drawings that use parts with the supplier codes. Cage codes are applicable to activities and parts provided for the federal government. CAGE stands for Commercial and Government Entity. This code is only listed if the part is purchased from the registered vendor. At one time, this was referred to as the Federal Supply Code for Manufacturers, known as the FSCM number. The material column lists the commercial name of the material used in marking the part. This may be a trade name, such as Lexane, or an industry abbreviation, such as CRS, for cold rolled steel. The procurement specification column furnishes the commercial specification and stock size of the part material. This column is sometimes labeled material specifications, sizes, notes, or suppliers. The names and addresses of the manufacturers of purchased parts are sometimes included in this column. The unit weight column gives the actual weight of the part. This information is typically supplied only when it is required by the contract. The weight of the part may be used for determining shipping criteria, and it may also be used to determine the overall weight of the entire assembly. An additional column for notes or remarks can be added to provide information related to a vendor's source, general notes, or on conditional information about the part.